All right, guys, part one of inverse functions. So we have another topic here that you guys would have learned about originally in Algebra 2. So let's just start with what an inverse function is. So an inverse is just a reverse mapping of a function. That's kind of a fancy way to say that if we have the input and the output, they're just swapping, right? So our input becomes our output and vice versa. Or if it's x and y, or x and our y are just going to switch. All right, so let's start off by looking at a graph. So I've got a graph of f of x right here. And so there's 3 points I'm going to highlight on this graph. So the first one is left one and up one. Then there's a point up here that goes through 0, 2, passes through the y-axis. And then this point is positive 1, positive 1. So if we were asked to sketch the inverse of this function, we would just go to each point and we would swap the order of the x and the y. And the negatives would go with whatever value it was attached to. So if I swap this here, the x-coordinate is now positive 1 and the y-coordinate is now negative 1. Right, so that would end up right here on a graph. Right, the x is now positive 1, the y is now negative 1. And again, I'm swapping the order. I'm not just moving the negative here. At the point 0, 2, well, if we switch x and y, now it's at 2, 0. I'm just switching the order of the x and the y there. And then our last point. So if we take 1, 1 and we switch those, well, it doesn't actually move, right? Because the x and the y were the same, so they're still going to be the same, even if we swap them. And so now what was a semicircle opening down, it's still a semicircle, but now it's opening to the left here. So that's what our inverse would look like. However, so the original graph is a function because, let me get a line here. There we go. All right, so if I took a vertical line and I put it right here, it's only going to pass through one point. No matter where I put that vertical line on this graph, it's only going to pass through the graph once. All right, so this passes the vertical line test, whereas on this one, if I were to draw a vertical line, right, it passes through more than one point. And so we're going to say that this fails the vertical line test. When the inverse fails the vertical line test, we say that the function is not invertible. And all that means is that the inverse won't actually be a function because it fails the vertical line test. Now, one way we can tell that this is going to fail the vertical line test is because on this function, if I took a horizontal line, right here, it would pass through more than one point, right? If I just put it on the graph there. So if the original function fails the horizontal line test, the inverse will fail the vertical line test, meaning that it's not invertible. All right, now we have a graph. And the first question is just, is f of x invertible? All right, so if we were to graph the inverse, would it be a function? So let's think about this. This we know is a function. It passes the vertical line test, but we're asking now about its inverse. And if I were to take that horizontal line, and this just doesn't want to work for me today. Okay, let's switch that. There we go. No matter where I have that here, it's only going to pass through the graph once, right? No matter where I have that horizontal line. So because the original graph passes the horizontal line test, the inverse will also be a function. We're going to say just yes, f of x is invertible here. Next question, what is the minimum of, and this is our notation for an inverse function, f inverse of x. So to answer these next two, let's go through and actually try to graph the inverse. I'll just switch colors here. So this was at the point, it was left 3 and up 1. And so negative 3, 1 is going to be at 1, negative 3. There's more points on this graph. I'm just going to take some of the key ones here, though. So this was at 0, negative 2. Now it's at negative 2, 0. And then this point was at positive 3, negative 3. So now it's going to be at negative 3, positive 3 up here. All right, and just like this was all straight lines, same thing. So connect them with straight lines. Just like that. All right, so this is our inverse function. You can tell it passes the vertical line test. Now we're asking what's the minimum of our inverse function? Well, the minimum is just the lowest point. All right, so that occurs at this coordinate point, which is x is positive 1, and then y is negative 3. All right, and so the answer might be written as a coordinate point, but usually when it's the minimum or the maximum, we're looking for just the y coordinates. We're going to put negative 3 here. All right, lastly, find f inverse of negative 3. So that's on the inverse graph. This would be our new x coordinate, right? Our new x coordinate, negative 3. This is just asking for the y coordinate on the inverse function. So when x is negative 3 on the inverse function, our y coordinate is just positive 3. So that's what f inverse of negative 3 is going to equal here. All right, last question. We've got a table, and it says, is f of x invertible? Why or why not? So to figure this out, I'm going to go ahead and just plot some points. All right, we don't know exactly what the graph looks like. But let's see what happens if I plot 1, 4. And I'm just going to 1, 2, 3, 4, 5, 6. I'm not going to even worry about the x-axis. But I'm going to go to 1, 4, and then 3, 6. And this is just to get a rough idea what the graph looks like. So 5, 5. 7, 4. And then we have 9, 3. Now, we don't know if this is just like a smooth graph here or if it's just random. These are just random points. I'm not going to connect these. These are just different points here. But I want to check if, because this is f of x, if I were to draw a horizontal line, does it pass through more than one point? Well, here we're good, right? So at 6 we're good. But let's check. I just keep doing this. There we go. Let's check 5, it passes through 1. But at 4, it passes through 2 points. So because f of x fails the horizontal line test, the function's not invertible, its inverse would fail the vertical line test. All right, so we're going to say f of x is not invertible. And the reason here, instead of just referencing the type of line test, we're going to say that f of x values repeat. All right, so our reason is because f of 1 and f of 7 are both equal to 4. And so because the f of x value is repeated, that would mean the inverse, again, fails the vertical line test if we were to sketch the inverse function. All right, that's it for this one, guys. Stay flawless.